Hello everyone, and welcome back to the continuation of conic section circle. So last time, I think that's part two, if I'm correct. Yeah, part two there. We actually discussed about converting a general form of a circle to its standard form, right? So let's have a recall. Like last time, we have a given general form of a circle, and then we convert it into standard form, and then this is the result, right? And another thing, of course, for the simpler ones, just like this, like x squared plus y squared minus 4, just simply group all the x squared and y squared, then the constant term to the right, and you have this as your answer. All right. And of course, we have like some sort of information about the concept of circle. Now, so what we're going to do today is we're going to continue, and by continuation, we're going to discuss about converting a standard form to general form, right? We know how to convert general to standard. Now we do it in reverse way, standard to general. Now, how are we going to do that? Okay, so there are two cases again. For the first case, like if you only have x squared, y squared, and then a given constant term, all you need to do is just group them, just group them all on one side. That's all, right? That's all. That is all you need to do. Again, if you see x squared plus y squared, and then there's a given constant, you know what you're going to do? Just group everything on one side, right? Maybe I made a mistake here. Hold on. Just for a second, right? Wait. Okay, just for a second. Just for a second. Right, there we go. So yeah, if your standard form looks like this, like x squared plus y squared is equal to constant, just group them all on one side. For example, I have x squared plus y squared is equal to 16, right? So if you see these, all you need to do is just group all terms on one side. So for me, in my case, I'm going to group 16 to the left. So if I'm going to put 16 to the left, what happens is that it will become negative. Hence, I will have x squared plus y squared minus 16 is equal to 0. And we're good to go. That is so easy to do. All right? So another one. If I have x squared plus y squared is equal to 8, what must I do? Just transpose 8 to the left. The result will be x squared plus y squared minus 8 is equal to 0. And that's it. That's the answer, right? We're good to go. And lastly, for x squared plus y squared is equal to 36, just put them there. So we will have x squared plus y squared minus 36 is equal to, wait, hold on. There you go, is equal to 0. And that's it. We are good to go. That's what you're going to do. All right. Long story short. Now, if you would notice, there's some additional steps, right? Just like what I said, group all terms on one side, right? Just like what I said here. Now, there's another step here. It says that arrange them according to their degrees in descending order. Basically, from highest exponent to the lowest exponent in this case, all right? From highest exponent to the lowest exponent. So here, if you're going to observe the order, we have the squared ones, and then we have the constants. So is it always like this? Yes. All right. If you're going to convert it into its general form, make sure that the highest exponent are the ones or the highest degree. But in this case, let's make it exponent, all right? Because since all terms are, what I call all terms have their own variables, they're not combined, if you know what I mean. So basically, all exponents, all right? No, sorry. All terms should be arranged based from their exponents. That's it. And then the order must be in descending order. So when we say descending order, from highest to lowest. So here we have the highest exponent. We will keep that. The next, the one has the lowest exponent, 16. Right? 16 has a zero exponent, okay? Has a zero exponent. So therefore, they shall be put on the last, right? So yeah, the pattern is again highest exponent, then up to the lowest, okay? So let's just say I have this one. Like for example, I have like All right, this is just another example. All right, I'm just gonna make this up. So I have, let's just say, uh, what do they call this one? I have this one, 16 plus y squared plus x squared is equal to 0, right? Like this example. So can this be our final answer? So if that's your answer, then no. Because the general form, again, it states that the exponents, okay, I mean, in terms of the order, should be from highest to lowest. So since these two terms have the highest exponent, they shall be put on the first place. So we can put either y squared plus x squared or x squared plus y squared. It's up to you. Actually, they're both correct. Y squared plus x squared plus y squared. But commonly, we often start with x. So we put x squared, then plus y squared. That's it. Then what's left are the next lower exponents. Okay, so plus 16 is equal to 0. Plus 16 is equal to 0. All right, so these are the format that you should do, all right, if you're going to convert it into general form, all right? Now, if you're asking me, right, before we proceed to the next part, is that why is it that the exponent of the constant term is 0? Now, assume that every term has a variable, okay? So that means the constant term should have a variable, all right? Just like what I said, assume that all terms have variable. So imagine that 16 has a variable, okay, whether it could be 16x or 16y, all right? Now, here's the thing. Why is it that the constant have 0 exponents, okay? Like, for example, 16x raised to 0. Why? Okay, why is it that it's always 0? Remember, I think that's identity property, I do believe. Or maybe it's zero property of exponent. I think it's zero property. Basically, if your exponent is 0, automatically that's 1. Okay? Anything raised to 0 is 1. But it would be a different case if the base itself is 0. Okay? 0 raised to 0, that's a different topic. Okay? Because 0 raised to 0 is, in other cases, indeterminate form. Or to put it in another way, it's undefined. Sorry, it's undefined. So it will give you an invalid answer. But if it's not 0, all right, just like, for example, 2 raised to 0, or let's just say x raised to 0, they all equate to 1, all right? So therefore, 16 times x raised to x raised to 0 is just simply the same as 16 times 1. So you have 16, all right? Which makes sense, all right, which makes sense because constant term exists as a number, no variable, all right? So therefore, the exponent, if ever there's a variable for a constant term, it should always be 0, all right? So that explains why the constant term is always the on the last order, or like on the last rank or last place if you're going to arrange them according to the exponents in descending order, right? So yeah, that's all. Let's now proceed to the next part. Okay, so yeah, good thing that we know how to convert the given standard form where it is x squared plus y squared is equal to 36. Okay, that's it. What I mean is that we know how to convert standard form to general form if we have x squared, y squared, and then a given constant term. All right. Now, how about if it looks like this? Like there is a squared binomial like this one. What are we going to do? Like, how should we, uh, how should we make this into, what do you call this one? Into a, yeah, basically general form. So first you have to expand them. All right, let me give an example. You see this one? We have to expand them. How can we expand them? Like you see this one, and this one. How are you going to expand them? You see, there are two ways for you to expand these parentheses. Okay, there are two ways. One, we will do it manually. All right. So x minus 1 squared, right, in this case, is just the same as x times quantity x times 1 times quantity x minus 1, right? They're just the same. The exponent simply tells you how many x minus 1 are there for you to multiply them. So since the exponent is 2, therefore there are 2 x minus 1s, all right, for you to multiply them together. Now you see, both of them, they are binomial. When we say binomial, it means it's a type of polynomial that has only two terms, which makes sense because you see, each of them has two terms, x minus 1, x minus 1. All right, that's it. So both of them have only two terms. So, okay, what are we going to do? So the first way to do it is by doing FOIL method, all right? By doing FOIL method. Okay? So how to do FOIL method? So F stands for first, okay? So first what? First terms, okay? You will multiply the first terms of the two binomials. So the first terms are basically on the left side, all right? The left side of the parenthesis. So these two, okay? These are the first terms. So x times x, you will have x squared, all right? Next, O. O means outer, okay? Outside. So outer terms. So basically, you're going to multiply terms that are basically beside the parenthesis outside, like on the outside part. So it meant that we're going to multiply these two, okay, because they are on the outer, x and negative 1. So x times negative 1 will give you negative 1x, or just simply negative x, okay? Next, we have the I. I, basically, the inner terms or the inside terms. If we have outer or outside terms, we have I for inner or inside terms. So basically, you're going to multiply the terms that are actually between, or like it's basically within the, what do you call this one? It's basically like the terms that are on the middle part, right? Terms that are on the middle part. And those are negative 1 here and x here. All right, they're in the middle, they're inside. So that is your goal. That is the, I mean, those are the terms that you're going to multiply. So negative 1 times x, you will have negative x. Okay. Then lastly, we have your L, which means last. Okay. So in this case, last terms. So you will multiply the terms that are actually on the right side of the parenthesis. Okay. Right side of the parenthesis. So that means in this case, you're going to multiply negative 1 and negative 1 since they are on the last parts, right? Or on the right side of the parenthesis, okay? So negative 1 times negative 1 will give you positive 1. Okay, so that's for method. Oh, wait, I forgot. You're going to add all of them, okay? You're going to add these four terms. So as a result, you will have x squared, then negative x plus negative x will give you negative 2x, then plus 1. So this is the expanded form for the square of x minus 1, all right? So this is it. I'm going to put it here. X squared minus 2x plus 1, all right? It's already expanded. Remember, when we say expand, meaning there's no parenthesis. Now, there's another way, which I do believe it's much, much better, right? This is much better compared to this one, all right? Which is a technique, an algebraic technique that is about expanding a squared binomial. Okay, expanding a squared binomial. Let me erase this one. All right, you can just pass backward if you want to know the steps of applying FOIL method. Okay, FOIL method is useful if you're going to multiply two binomials, just like this in this case. All right, we have x minus 1, x minus 1. You can use FOIL method. But there's another way. Okay, this is actually a useful algebraic technique. In fact, I actually often use these in my college days, and they're very helpful, right? This is only useful if you have a squared binomial, okay? Just like this, okay? Just like this, okay? If you see binomial and then there's a parenthesis outside and there's an exponent, that means it's a squared binomial. So if you have a given squared binomial, just like this, square of x minus 1, so how would you expand it? So follow the steps. First step is you are going to square the first term. Square the first term. So what's the first term? The first term is on your left side of your parenthesis. This one, okay? Square it. So you're going to square x, all right? So as a result, you have x squared, okay? The square of x is x squared. First step. Second step is 2 times the first term times the second term. All right. So the second term is the one on the right side of the parenthesis. Okay. So you will have 2 times the first term, x, times the second term, negative 1. Then you combine them, that will give you negative 2x. All right. Then lastly, the third step is you're going to square the second term. So in the second term, you're going to square negative 1. Okay, remember, second term is on the right. So here we will have negative 1 squared. So negative 1 times negative 1 will give you positive 1. Right? Then after that, you add them together, like you combine the results. X squared plus negative 2x plus 1 will give you x squared minus 2x plus 1. All right? So that's it. So this is, in fact, much better, in my opinion, compared using FOIL method, all right? Now, if you're asking me, right, you're going to combine them, like x squared negative 2x plus 1, right? You're going to combine them, all right? So that means you have to add them. But if you're going to add them, why is it that 2x is minus, not plus? Because you're going to add them, right? So you can skip this part. If you know, okay, you're good. But if you don't know, I'm going to explain to you why. It's because like if you're going to add them together, this is the result, okay? I mean, this would be the process. X squared plus quantity negative 2x plus 1. You see, this term is in negative. So if you're going to add a negative term, you have to put a parenthesis. Okay, you have to put parenthesis because it has a negative sign. Now, if you would notice, plus and negative sign are what? Are basically beside each other. So imagine you multiply them. Positive times negative, plus times negative. Remember that in multiplication, if you're going to multiply a positive and a negative, the answer would be negative. So in this case, plus times negative will give you what? Negative. So you have negative 2x plus 1. So therefore, you have minus 2x instead. All right? So now you know. All right, let's go back. So here we have the expanded form of the square of x minus 1. Now let's do the same thing for the square of y minus 2. All right? Let me erase this one. And I would rather use the second method because for me that's much much better. All right? You can picture this one if you want to what do you call this one? If you want to memorize this, all right? Again, this technique is only useful for the squared binomial, okay? So, let's proceed, okay? Let's expand this one, okay? The square of y minus 2, right? So, first step, you square the first term. So, the first term is always on the left side, which is the y. So, you will square y. So, the result would be y squared. Next, 2 times the first term, which is y, times the second term, which is on the right side, negative 2. All right, so negative 2. So 2 times y times negative 2 will give you negative 4. And lastly, you're going to square the second term, which is basically on the right side of the equation. So negative 2 times negative 2, or basically negative 2 squared, sorry, the answer would be 4. Now you add them together, and that is your result. So you will have plus, add the y squared, negative, oh wait, sorry, negative 4y plus 4. You will get y squared minus 4y plus 4 is equal to 2. That's it. Don't worry, we have some couple examples, right? So let's have like a few practice. Okay, now let's proceed. Now, what are we going to do? Okay, now we will group all terms on one side of the equation. Okay, equation. Actually, there's one more step I would like to include here. Okay, there's one more step. Let's do it later. Okay, so we have two here. Let's put them on the left side. All right, so we have x squared minus 2x plus 1 plus y squared. Wait, hold on. Y squared minus 4y plus 4 minus 2 is equal to 0. All right, there's one more step I would like to include actually. All right, there's one more step. Okay, I might need to move the solutions here. Okay, I might need to move that. All right, hold on. Just give me a moment. All right, I'm not gonna erase this method. All right, I want you to use this if you want to. All right, which I highly recommend you to do so so that you will have a practice. Okay, but if you don't want, you can just disregard this method, right, in terms of expanding a binomial. But anyway, okay, so there's another way. There's another step. Okay, another step here. Oh crap, I can't press. Like, I'm gonna put it here. All right, another step here to include is combine similar terms. Okay, combine similar terms. Okay? So there are terms out there that are like or similar, so you can combine them. Okay? So let's start first with x squared. So are there any terms that has x squared aside from x squared itself? No one. So we're just going to leave it. 2x, negative 2x. Are there any terms that has x or x only, just like negative 2x? None. All right. How about 1? 1 is a constant term. So are there any terms that are also constant term? Yes. Because aside from 1, we have 4 and negative 2. So since 3 of them are constant term, we're going to add them together. All right. So 1 plus 4, that would be 5 minus 2, 3. Am I right? 5 minus 2, 3. Okay. So as a result, let me just copy the other terms here. Negative 2x plus y squared minus 4y. All right. So this would be positive 3 is equal to 0. All right. Now take a look. Okay. How about y squared? Do you think there are other terms that have y squared aside from this? Nothing. How about negative 4y? Are there any terms that have y aside from negative 4y? Nothing. So those terms that don't have like terms or similar terms, just keep it that way. But for the constant terms, I highly assume that there would be more than one terms or more than one constant term. So there, you have to combine them together. So you have this one. Now, okay, what are we going to do? Now, the last step is you're going to arrange them according to their degrees in descending order. Basically, from highest exponent to the lowest exponent. So we have x squared plus y squared. They should be on the first place. So we have x squared plus y squared. Next, the next one, we will have negative 2x and 4y. Why? You see, if you would just see x and y, according to the identity property of equality, I hope I'm correct, all right? X is just the same as x raised to 1. Y is just the same as y raised to 1. So therefore, they should be on the second place. So we have negative 2x minus 4y, all right? Then lastly, the constant term, which I already explained, that the exponent of the variable 0, so we will have plus 3 is equal to 0. And this is your final answer, all right? So if you would notice the pattern, this is actually the best the most recommended or common way to represent a general form of a circle. Okay? First is by descending order, right? X squared, y squared, then x, y, and then constant term. All right? Not only that, when it comes to the exponent, but also the pattern of the variable, like x, y, then x, y. All right? Commonly, that's how they are formed. If we have x squared plus y squared, then the next term would be x, the next would be y. All right? xy, xy. All right? So that it would be properly arranged. All right? So that's it. Okay, let's try another example. Okay? We have this one. Let me just copy these. I copy this. There we go. Okay? Again, it's up to you, okay? It's clearly up to you if you're going to use this technique, okay? It's up to you. I'm just helping you, all right? So, all right, let's convert this standard form into general form, all right? So we have this one. So how to convert the square of x plus 3? First step is you square the first term. So remember that the first term is basically the left side. So square x, you will have x squared. Next, according here to the second step, 2 times the first term times the second term. Okay? So the second term is basically the right side of the parentheses. So you will have 2 times x times 3. So 2 times x times 3, 6x. And lastly, you square the second term, which is the right side. So here, you will get 9 because 3 squared is 9. So here you will have x squared uh, plus 6x plus 9. That's it. All right. Now, how about the square of y plus 4? Why, the same thing. Okay. So again, you square the first term. So the first term is again to the left. So you will have y squared. Next, the second step, 2 times the first term times the second term. So that means 2 times the first term y times the second term 4. So you will get 4y. No, wait, no. That's 8. Why? It's 8y. Forgive me, 8y. 2 times y, 2y times 4, 8y. That's it. Then lastly, you square the second term. Square of 4, 60. So you will have plus y squared plus 8y plus 16 is equal to 10. So you're done with the first step. You expand everything. Remember, expanding means no parentheses. Okay, so what's next? Now you're going to group all terms on one side. Okay, you will put 10 to the left. So you will have x squared plus 6x plus 9 plus y squared plus 8y plus 16 minus 10 is equal to 0. That's it. Now, what's the third step? Third step is, I forgot to tell you, you combine similar terms. So x squared is alone, 6x is alone, y squared is alone, 8y is alone. But for the constant terms, however, they're not alone. 9, 16, and negative 10, they are constant terms. So they are like terms or similar. So we're going to add them together. All right? Let's start first with the simple one. 16 minus 10. That would be 6. 6 plus 9, 15. Okay? So you will have 15 as your final answer. So let me just copy the other terms. Okay? We have this one, then plus 15. Yeah. 60 minus 10, 6 plus 9, 15. Yes. Then what's the last step? Last step is you're going to arrange them according to their what exponents in descending order. Highest exponent to the lowest exponent. So x squared and y squared will be on the first place. Okay. Next, the second place are the x and y's because their exponent is raised to 1. So we have plus 6x plus 8y. Then lastly, we have the constant term as the last place. And there you go. This is your general form for the given standard form. That's it. That is how you do it. Now, I want you to try this on yourself. Like the square of x minus 2 plus the square of y minus 5. All right? Don't worry. After this video, I'm going to provide a practice video. Okay, before we proceed to the next part of circle. All right. I mean, next section of the circle that we will still discuss. All right. So that is all, guys. See you soon.